Hello and welcome to the next night of Advent of Code. Getting ready for the 21st problem. About 20 seconds left to go. Let's get my environment set up here. All right. Looking pretty good. Got lots of colors on the Advent calendar. Let's see what problem is in store for us tonight. Okay, here we go. Fractal art. Generate. All right, so we have a grid. Okay. This program has a size of 3. Program repeats the process. If the size has this, it breaks things up. Otherwise, it's got to be like this. All right, so it's got to be evenly divisible by 2 or 3. Okay, each square of pixels is replaced by a larger one. All right, is nearly your puzzle input. Is nearby, I see. The artist explains that sometimes you have to rotate or flip. Oh, I see the input pattern. Okay. Each pattern is written concisely. Okay. Okay, when searching for a rule to use, let's take a look at the input. Okay. All right, I think I kind of get this. All right. So, all right. Rotate and flip the pattern as necessary. All of these patterns match the same rule. All right. So if the book contains these rules, then it begins the size of the grid. It divides evenly into a single square. The square matches the second rule, which produces. Okay. Each of these matches the same rule. Okay, joined into a new grid. Thus, after 2 iterations, the grid contains 12 pixels. Okay. Okay. Well, program always starts with this pattern here. So maybe start, which is something like maybe this, here, maybe a vector of 3 vectors. All right, so 3 rows. And then these are the rules. So let's save this. So let's see if we use our smart parser on this here. How the rules look. They look fairly good. I think probably do want a parser for source something dest here. Yeah, that seems pretty good. And then for source, we're basically going to do like, I think we can kind of do like a split on the slash character. Maybe like this. This might be okay. And then map vec to something like that. Okay, and then the other part of it, map vec. Okay. All right, so let's see if this actually does parse the rules. So I'm gonna try P on the first rules here. Okay, defin. Okay. Number of args passed in makes sense. Okay, and then this is saying that looks like the source rule. So let's do this just to make this a little bit easier to look at here. So this is saying our source here is ... and then it's all says it generates this. Okay, okay, so far so good. Now, we need to be aware of rotates and flips. Okay, so let's see. Rotate and flip the pattern as necessary. So it seems like maybe we say uh, maybe like the alts of a pattern are, so take this. Ah, okay. Okay, a so a flip seems easy. That's just a horizontal flip. So we're just going to map the reverse to the pattern. So that's one. Another one is we reverse. So in this situation, we just reverse. We have like a vector of reverse the pattern, like that. And then I think the last one is something where rotate all the following patterns. Maybe we're supposed to do more than. Oh no! I think I get this. So this is not. So this is a reverse, and then this one here. So rotate. I think it's just transpose. So I wrote a transpose. Let's try this here. So let's ask what the alts, oh, and then of course the pattern itself. Okay, so transpose. Let's ask what the alts of the starting state are here. Okay. Okay, I think I need a printer. And then apply stir to interpose new line of map stir to print line this. Okay. All right, so let's see. Okay, first of all, I just want to make sure. Okay, and can I also, okay, so I think I want to change this to apply stir. Okay, nope. Okay, how about just these? All right, this looks pretty good. So interpose, new line, map, stir. Okay, then how about the second? So this one, yeah, this looks good. Okay. Okay, that one looks good. And then this one, okay, this is transposing in the other direction, which makes me think that I'm like missing a rule, which is like, I gotta do this too. Okay, so this is right. So basically, you have the starting position, you got a horizontal flip, a vertical flip, um, and a transpose 90 degrees and negative 90 degrees. What about two flips in a row? Is that the same thing? I don't think this is any different here. let's see, no, transpose on transpose just is, oh no, this is different. Is it correct? Here we go. Sometimes rotate or flip. Never rotate or flip the output pattern. Each pattern is written concisely. Ugh. I wish I had a better definition of rotate and flip. So let's see. One must rotate or flip. Okay, it says rotate or flip, but it doesn't say rotate and flip. So I'm going to say that since we have 2 rotations covered and 2 flips covered, that this is good enough. All right, so now I have to find the matching rule for an input here. So I basically have to say, like, for A in the alts of the input, all the alternatives, and then for R in the rules, when, so a rule R consists of a source and a dest here. Okay, and then this is trying, I think it's saying that, okay, and then in this situation, I think we're talking about just emitting the destination here. So if we have, okay, so what's the first of the rules here? So it's saying dot, 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 dot should produce this. Okay. Actually, I'm gonna have this take the rules as input here because I want to map P to rules. Actually, no. These are going to stay as rules, but I'm going to map P up here. Okay. Now it's the first of rules. Okay, this does look like a production. And then, so where's our start? Start looks like this. All right, so let's try it. Let's try matching rule from our start. Nothing. All right. So one of these things ought to match our starting state here. Okay. Maybe now count to rules. All right, every rule consists of 2 things. Look at the first two rules. Let's try calling matching rule for an input where it's like this here. So inputs are dot 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 like this. So this situation, it seems to work. In fact, it seems like there's multiple ways to sort of interpret this. All right, so let's see. Okay. Suppose the book contains these patterns. As before, we start here. This one has got to match this one. So out of curiosity, does this show up? No. But we know that I wonder if just looking at these patterns here. So I wonder which one of these it would be. And if there's a way to figure that out. Well, I think that it's either this one here I mean, I must be missing one of the alternative ways to do this. So, all right, rotate or flip. All right, so we know that we are covering all of these patterns match the same rule, which is correct. And when I do matching rule here, hopefully the count of this is 4. It's 5. Oh, right, because we got five different patterns. The problem that I'm hitting is I'm not matching any pattern to the start state here. Okay. All right, so the definition of alts must be wrong. Let's see. All right, let's stare at this. Stare at this starting state. um, let's see. So here's the input. When, yep, okay. All right. So here's one. This is a horizontal flip. This one is a vertical flip. This one is this a rotation? So let's see, starting here, rotate up like that. So I don't see, this is not a rotation here. So I need to fix this. This other one is a rotation. So I, huh. Yeah, let's stare at it again here. Okay, so if we flip this whole thing up, so this one is good, but if we rotate it this way, then this guy needs to be up here. That seems to be the case. So what's worrying here is that my transpose seems to be wrong. We'll clear this out. Here's what we start with. Horizontal flip, vertical flip. Then in this situation, there's the line. Then here's the L. Yeah, this doesn't seem right. So I think transpose right now is not right because it isn't doing an actual rotate. So maybe this is just as simple as I have to reverse the transpose. Something that simple. All right, it's the fourth one of 5 that we care about here. Okay, this looks a lot better. All right, so now let's see if anything matches the rule. No. All right, so I guess if this operation is a rotate, then by 90 degrees, then this operation should be a rotate by 180 degrees. Oops. Okay, wait, nope, undo. Because we need to make one more of these. All right, so transpose a reverse of this thing here. Okay, so yes, this does look like this is a 180 degree rotation. Okay, all right, still no matches. Okay, compare this to this. Okay. So we have these rules here. So I guess the other way of doing this would be to work off all the different alts of the rules, but that should be the same thing. Maybe I have to flip and do these rotations in the same one. So I guess that would be like adding so many more of these. Like, I guess like a reverse on this, and so like so this is the so I guess like a reverse on each of these here. Reverse, and then a map reverse on the rest of these. Something like this. Can I get a rule to match now? All right, well, we did get a rule to match. What's the count? So 2. So my guess is that, well, let's at least tell me that this is set containing, okay, at least this is a set containing just one thing. Yeah, because otherwise I would be very upset. All right, so then it divides it into these things. Then this divides it into four grids. Okay, so it puts it into this. Now I think we need like split up here, taking some state and basically if the count or if even, can't spell, if the count of the state is even, then okay, convert each 3 by 3 square. Okay. Break it up into 2 by 2. Okay. So this is the important one here. This is where I basically need to. Okay, so this should be fine. I think that pretty much the only production rule that matters is the 4. It's just the four back into 2s. So basically, what I need is I'm going to have a vector of 4 things where it's like, so I need to like take 2 from state and then like map the take 2 from this thing here. All right, so this is going to get the top 2 things, then next 2 things, then take 2 of this, and then drop 2 of the drop 2. Okay, I like this. If it isn't even, then I think you just need to return a list containing state here. All right. So five iterations. So so let's see, what's an iteration? So in an iteration, what we start with is a collection of mini grids. For m in mini grids, let the destination rules, I'm just going to say the first of call matching rule on the mini grid M. And then we got to follow the production rule. So then for MM in split up B, then just emit MM, something like that. Therefore, if we're in a state, so if we call I on just this here, this gives us something. All right, so can we then call I on this? The answer appears to be yes. All right, so then let's say iterate I starting here, and then we want to take the nth fifth here because this is after 5 iterations. Okay. And now we just need to know how many hashes are set. So how many pixels stay on? Map. Okay, so each of these mini grids. Actually, can I just do a print line on this here? And just like a grep for this here. That doesn't work because this is counting lines. Can I turn all spaces into new lines? Yeah, but can I be sure that none of these have more than one? Just scan it real quick. Yeah, it looks like none of them have more than one. So grep-c for the hash character. This does give an answer. Let's try it. Not the right answer. Okay, my guess is that I'm not matching a production rule here. So let's say if nil d notify us that there's a problem. Interesting. So it says actually that there isn't no problem here. Did I not? Okay, well, I guess that's pretty good. I guess the other thing, if it's not the case that 1 is the count of the set of things that match the rule, too many here, because that would also be a problem. Also not a problem. Geez, I hope I just didn't screw up the way of counting these things. Okay, so each of these is a mini grid. So for M in each of these mini grids, for row in M, for C in row, when equals C a hash, emit 1, and then sum. Okay, so good and bad news. My thing seemed to have worked, but all right. Thus, after 2 iterations, the grid contains 12 pixels that are on. All right. Well, so here we go. Okay, here's input 2. Now let's make our rules 2. Here, and matching rule goes off of this. All right. And then, yeah, let's say take this after 2 iterations. So this does give the right answer. Actually, this does give 12. How many pixels stay on? Okay, we guessed this, which was not right. Interesting. So we find a production rule for each of our little mini grids. I think, so what's the issue? So I think the issue is the 2s get turned into 3s. then the 3s are then even. So evenly break them up into 2 by 2 squares and convert each 2 by 2 square into a, yeah, so the problem is in this step here, in the split up. Yeah, so basically I have to say, like, for each of the rows in a partition 2 on state, so each of these is going to be a list of rows, and then I think for each of the, maybe something like, gotta, so this is going to break them up into 2 rows, 2 rows, and 2 rows. Then, maybe it would be easier to talk about for I in range 0 up to count of state growing by 2s. So yeah, and then for J in same thing. Then what I want to emit is this. Take take 2 from drop I, and then take 2 from drop J here, and have this be a vector. Okay. All right, so now let's turn the rules back like this, and start here. Same answer. Let's see. Change split up. Okay. Okay. This shouldn't be the same answer. Okay. Finally, all the squares are joined up into a, oh, it's because I'm not joining them up into a big grid. I think that's the problem. I'm continuing to treat them as mini grids. Yeah. Okay. So, okay, yeah. So my split up, I think my split up is right. The problem is that I continue to treat them like mini grids. Okay. So I think, okay, so uh, maybe it's better to define, maybe it's better to define this recursively and to say, like, in split up here, we might have like a depth like this, and say if 0 is the depth, just return the state. And otherwise, we want to, like, apply the production rule to each of these things. Something like, apply rule to some m here, going by a depth okay, this should just be a regular let. Okay. Okay, and then take one away from depth here. And then am I going down the right path here? Convert each 3x3 square into a 4x4 square. Convert each 2x2 square into a 3x3 square. Let's take a step back here. Okay, so start with the start state. Start with, okay, I've already made some changes. All right, so I want to say something like apply rule to start with a depth of 5. Now, what apply rule does is it takes state and depth. Okay, and this is going to return a collection of grids, basically, a collection of these mini grids. And then basically, if 0 is the depth, I can just return an empty list. Otherwise, I'm basically going to do a map. So I think this is appropriate-ish. So given this state, I'm going to find the matching production rule. Okay, and then I think my split up is also fine. Doesn't need to take a depth or anything. Wrong number of arcs past 2A4. Yeah, okay, like that. Okay, so take what comes out, split it up, and then I think okay, I don't want this to be in a 4 anymore. Matching rule on the state here. Okay. Okay. And then I think I want to apply concat to map apply rule of this thing in 1 less than the depth to split up on D. Yeah. Yeah. I think I like this. This should give me something. Oh, nothing. That's nice. Okay, so let's see. So we do have a starting state. If I call matching rule in the starting state, okay, so this gives something. And then if I call split up on that, okay, that looks good. And then I think it's saying that I can't map apply rule. No, because it's so maybe I've got to have like a return variable here. Does that make sense? You have a set of mini grids. I think when you're done, okay, I think when you're done, you just need to return the current state that you're in. Okay. All right. So, okay, this gives a big thing. All right. Okay. That's funny. And once again, it says that all the production rules are satisfied. What? If you apply rule to a depth of 0, then you just get the current state back. Otherwise, get what you get from applying the rule to, in the case here, you're going to do a split up. What the? If in this case you break it up, which we're doing, okay, it's only ever 3 or 4. So in the case where it's, I mean, in the case where it's 4, where it does seem like we're returning the right thing, I mean, I guess we could test this function here. If I call split up on 1, 2, 3, 4, 1, 2, 5, 6, 1, 2, 5, 6. Okay. Yep, this is wrong. Take 2 from the drop J. Okay, well, this is good at least that we found a problem here. But map take 2. So for values I and j, it's saying drop 0 and 0. Okay, got that. Then it should be saying drop 0 and then drop 2. Okay, this is wrong somehow. Maybe, I mean, we could put it back to the way that it was with list of well, hang on. We should be able to fix this thing here. Okay, so for these values, I think I think maybe the only thing that's going on here is that these just need to, there just needs to be 4 by 4. No, hang on, this is 4 by 4. This is definitely the wrong thing. Okay, I agree with the first one. Okay, so then the second one, this here, my state is this, and I'm saying drop 2 here and drop 0 here. Take 2 from drop 2 of this. Oh, maybe it wasn't such a great idea to repeat these. Yeah, well, I think that the answers that it's producing are no. Okay, that was just wrong. Okay, so this is making the right answers. Okay. All right. Okay, thus after 2 iterations, the grid contains 12 pixels that are on. Yes, I agree. This is what it looks like. How many pixels stay on after 5 iterations? How many pixels? Okay, let's see. So the size of the grid divides evenly, matches a single rule, which produces this, splits it up, produces each of these. Finally, they're joined into a single grid. Okay. And I think the only reason that they're joined into a new grid is that we've stopped, because otherwise this should have just applied the next rule. Okay. Well, okay, so agreed that we don't need this part here. We just need to split up rule. This thing, answer 45, which is the answer that we tried, right? Yep. Let's see. Well, maybe let's look at the output. So, well, I guess there's another possibility here, which is maybe there are different levels to, I guess here, let's look at this. So applying the rule once yields this, which looks, I mean, it looks fine. Okay. 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 Yeah, I mean, so maybe, okay, so let's actually, here, let's try applying the rule going back. Let's try switching this back to rules 2 here. Matching rule needs to be switched back. Okay. Answer 12, which is what it says. Okay. Let's take out some of this stuff. Keep our code kind of clean. For C and row, we just emit C here and take like the frequencies just to this. All right, so it says there are 12 hashes and 24 blanks. That's a total of 36, 6 by 6. Okay, so this number should be a square, I guess. Let's turn this implementation back and apply this 5 times. Okay, 145 plus 111 is 256, which is 16 squared. It seems like we go from 3 to 2 to 3 to 2 to 3. And if we add all these up, we get 13. Well, actually, so we start with something that's 3 by 3, and then we're going to add 1 to it because it becomes a 4 by 4. Then each of the 4 by 4s come get an extra 1 added onto that. Okay. So after 2, then it's 8 by 8. And so then there's going to be, oh no, hang on. So it should go 3 by 3 to 4 by 4 to 6 by 6 to, let's see. Okay, because the pattern said to have a size of, then the program repeats the following process. If it's divisible by 2, break it up and convert each 2 by 2 square into a 3 by 3 square by following the course. Okay, I mean, into 2 by 2, okay. If it's evenly divisible by 3, break it up into 3 by 3 squares and convert each 3 by 3 square into a 4 by 4 square by following the corresponding enhancement rule. Oh, okay. My interpretation of this is that I have to like merge the grid back together, and that I can't, that I'm not supposed to be doing this recursively. Does that make sense? I guess, because in a situation where it's 6 by 6, then these really do need to be broken up into two by 2s. So, I mean, that's got to be it. So if I have split up on, 3, 4, 5, 6, I wonder if there's an easier way to do this. Split up map back to split this string up by new lines here. Okay, so and then finally, how big is the set of these things? So, okay, take this off. Okay, so this says 8. So 1, 2, 3, 4, 5, 6. Okay, and then if I don't take the set of it, 9. Okay, so yeah, this would seem to be it. So all right. So okay, so here we call split up on D. Apply. Okay, so given that you're in a certain state, so I think that pretty much what we got to do is, the first thing that we got to do is called split up on D. And then for like I in the mini, for M in like the mini grid of it, let D be this thing. All right, I'll leave these in. All right. And then, so now we're going to apply the production rule. So emit D here. Okay. And then I guess we'd like some kind of merge grid. Given a sequence of these. So just double checking on this. All right, so these go in an order that is not very convenient for me. If I just switch around these names, does this make it any easier? In fact, it does. Okay, so if I want to merge these back together, can I maybe map apply concat to each of the things inside them? Okay, so yeah, okay, so that looks pretty good. So basically map v spec apply concat to the mini grids. Okay, so then this merges them back together. All right. So now I think depth can be taken off, and this can be sort of left like this. All right. So now we have merge grid. We have a new definition up here. We got, right, wrong number of things passed into a 4. Okay. Unable to resolve D. What? All right, let's need to split up the state. Okay, so let's apply rule starting with start. And this should be fine. And I should be able to apply rule to this. All right, and we hit problems. All right, is that because split up doesn't want to work on this? Correct, it doesn't. Okay, so I think merge grid doesn't work because split up returns a collection of things. Yeah, I'm pretty sure that's, well, is that what it is? Well, so it does return a collection of things, but then this does look like it, so this looks like it puts them back together again. So the problem is that we're iterating over each of the, okay, so I think that basically let D be this. No, this still looks fine. Okay, and then okay, so I think the problem is that this isn't right. So okay, so split up the starting state returns just the one thing. That's correct. And then when you do a merge grid on this, okay, so it's unrolling them. And why? It seems like it should just be returning a list here. Like, I don't see the difference. I mean, I could go like this, but I don't think that's going to give me the right answer. Maybe. Yeah, this isn't right. Okay, so split up returns a list of states. For each of these things in the sequence of the list of states, you're going to call this. Merge grid takes the output of split up and puts them into a single grid. So, all right, I think what this is saying is that if we are splitting up something else, like this, that it is the wrong answer, which is true. But okay, I think I see why. Do I see why? So this shouldn't change anything. Okay, this returns a list containing this grid. This returns a list. Okay, this list containing 4 grids. This returns a list containing 1 grid. Okay, merge grid has never worked. Yeah, this is the problem. Yeah, merge grid definitely doesn't work. Okay, so all right, so we just have to fix this. So the issue is that we got something coming in this, and then we need this to emit 1, 2, 3, 4 as the first thing. Okay, so okay, so how do we do that? Um, okay, so these are going left to right at least. About a partition. Nah. Hmm. Well, so let's see. We want to take basically this thing followed by this thing and concatenate them. And then this thing and this thing. Can we do maybe the reverse of this here? Some kind of get in. There might not be enough here. I might need more. Um, let's just see to sort of understand what's going on. Okay. So if we were talking about the order that we had to pull these elements out, then we would say 0, 0, 0, followed by 0, 0, 1, followed by um, uh, let's see. So what is the first here? Okay, so then we have to go into the second thing. First position like this, and then like that. And then this becomes like the top line. And then the next thing is like this, followed by that. And so it does seem like you do want to do like a partition 2 on it. Okay. So so these are like 2 rows in a partition 2 of the mini grids. And then for these, what do we do? Can we do Hmm. Hmm. So, so we have a list here containing one element, and oh no, I see. We have a list containing two elements, of course. All right. So a list containing two elements, and then we want to sort of combine them across. So, uh, so apply concat is this is not right at all. Um, app apply concat is not right either. Um, what we need is um, can we like interleave these? Would that make sense? Um, to so what we want to do if we had a thing containing two elements where the first one was a pair through 1 2, and the second one was a pair 3 4, and we wanted to produce 4 6 out of that, then is it's apply map plus. So I think that we want apply map concat. Okay, apply map plus to list 1 2 3 4. Ah, oh, it's really unhappy about this right here. All right, so that's good. Now if our lists just become, if these just become this, then I should be able to just do this. Yeah, okay. So apply map concat. Okay, so then our merge grids for each of these things, apply map concat to the two rows. And so this is going to give me a collection of things, and then concat to the thing at the end. All right. Then otherwise, I think I can just return this. They're cowardly. In fact, yeah, maybe actually what I want to do is just the analogous thing here. That. 3 rows. Okay, so how about this? Okay, how about this case? All right, so this is actually correct. All right. Okay. So now that this is correct, and then this one isn't. Why not? Okay. I think it's must be something like this maybe. No, that doesn't work. Back of this. Okay, so maybe we'll just ignore the 3 case for now. All right. So now we have a different merge grid. Okay. So now we should be able to apply rule like this. All right, but there are problems. All right. Okay, can I not apply the rule at the start? Okay, I can. All right, and this does seem to have given a merge grid. Can I split this up? Yeah, this looks good. But yeah, it doesn't like these. It says in some cases it can't look something up, and in other cases, all right. Okay. All right. Okay, so it looks like that I can split up and then map matching rule to the output just fine. And can I merge grid what comes out? So this looks like yes. Okay. And then can I split this up? All right. Now how about here? This seems fine too. Something about apply rule having some kind of problem maybe? I couldn't. Huh. Well, so apply the rule once, then this applies it again, then looks like this applies it again. Can I merge grid? So looks like no. So this gives me all of these three things here. And yeah, the problem is that my three case isn't quite right. Yeah. So, yep, so this definitely is not right. We could have a special case for like count of mini grids is one, just to, and we need handling here. Okay, so let me define this to be something. So I applied it once, twice, three times. So iter 3 is what I'll call this here. Okay. So let's talk about iter 3. There are 9 mini grids in there. It really does feel like I should just do this to them. And this ends up with something. So this does give us a 9 by 9. So I merge grid this. This doesn't actually look right. Hmm. Hmm. Well, we're almost an hour and a half into this. I'm gonna see how other folks did on it, because if they did especially well, then maybe this is something. All right. So it seems like people. Yeah, there seems like a little bit of a struggle uh, on this here, but I'm also wondering if there's maybe some insights that I'm not particularly getting. I don't think so. I think it really is just a matter of, can you um, can you take a grid, can you split it up into a bunch of smaller grids, and then can you iteratively apply an algorithm? So unfortunately, it seems like the answer for me, at least tonight, is no, I can't do that. So yeah, it seems like I got as far as applying the rule 3 times, which is pretty close. I could maybe try, I don't know. Yeah, like, so this 3 iteration thing here consists of, I guess, 81 points in a grid that I'm just having trouble merging together. Did I not retry this here? Yeah, so the first thing, actually, here, maybe I should talk about what's the first thing here. So the first thing here is actually a group of, okay, so maybe I'm not, so maybe this is bigger than I thought, because this is actually, okay, so, so the seems like the music's playing me off here. Don't know what key I hit to start that, but this seems like they need to call it. Thanks for watching, and when I get a solution, I'll post it up. All right, thanks.